Section 6.2, Algebra 2, we're talking about solving quadratic equations by graphing. Our vocabulary is short today. We've got quadratic equation, which is an equation in quadratic form, so it could look like ax squared plus bx plus c equals 0. So this is oftentimes the way we're going to solve a quadratic equation, by making sure our quadratic equation is equal to 0. When we solve quadratic equation, the answers, or the value for x, are called roots. So the root of the equation, or the roots, would be the solution or solutions for x, the values that are going to satisfy this particular equation. And similarly, the value of x, for which makes this equation, oftentimes written in the form y equals ax squared plus bx plus c equals 0. Any x value that will make this equal 0 is what we would have in terms of a 0. So honestly, these guys are often referred to as the same thing, a 0 or a root of the equation. Let's take a look at some examples. So in this situation, in example 1, we're going to have two real solutions. And to solve this equation, we're going to solve it by graphing. We're going to graph the associated equation, or the associated equation with this equation. So the associated equation is y equals x squared plus 6x plus 8. And if I graph this guy, the thing I do is I find my vertex value, which I did my negative b over 2a, plug that into the equation, and I found the corresponding y value. Now that I have the vertex, I can easily just plug in negative 4 into this equation, and I can see what's happening on the other side of the vertex. When I plug in negative 4, I get 0. When I plug in negative 5, I'm going to get a positive 3. And the same thing's going to happen over the other side. So basically, I'm exploiting symmetry. When I graph that, I come to my x-axis and I make sure I can put these values in. So my vertex is at negative 3, negative 1. So my vertex is somewhere down here. These other 2 points, negative 2, 0, negative 4, 0 are here. And finally, my final 2 points, let me see if I can make this a little bit neater. My final 2 points are going to be here, here, and here in order to get this shape. So now, what did we do? How can we solve this equation right here? To solve this equation, we need to determine what x values will make this thing equal to 0. What x values are going to make this thing equal to 0? We know all these values for y, right? But what x value will make our y value 0? That's what we want to do. We want to figure out what's going to do that. And we can come over to our table and see that. When we have a negative 4 and a negative 2, we get a y value of 0. Specifically, those y values are found right, those x values are found right where the parabola crosses the x-axis. That's where my y value will be 0, at these 2 points. So the solution for us is that x is equal to the set, because it's equal to more than 1 point, of negative 2 and a negative 4. Those are our solutions to this problem. Let's look at another one. As we consider what can happen with these equations, we need to think about what can happen with our graph, because it indicates what kind of solutions we have. As we saw, that last equation, we had a situation where we had 2 different values that would make our function equal 0. So we had 2 real solutions. Sometimes we could have just 1 real solution. That's when the parabola only intersects the x-axis 1 time. We will have 1 root, or 1 value that's going to make this function equal to 0. But weirdly enough, sometimes we can have no real solution, and that's when the equation is floating above, or sometimes even floating below, this could be another situation, the x-axis, never to intersect. So we can have 1, 2, or no solutions. With that in mind, let's consider example 2, 1 real solution. Here, we're given this equation and we're asked to solve it by graphing. The thing that we know when we solve by graphing, we want to start off with this equation and replace it with this equation, graph and figure out what the x-intercept is. So we're going to do that here. First thing I need to do is push everything over to one side. So I'm going to do that by moving x squared over to one side and moving the 8x. So I'm left with 0 is equal to x squared minus 8x plus 16. The next thing I'm going to do is graph the corresponding equation or the corresponding function, which is y equals x squared minus 8x plus 16. To graph this guy, I'm going to do what I did before by first finding my vertex. My vertex is negative b over 2 far. It's going to have 4 as the x term, and when I plug 4 into the equation, 4 squared is 16 minus 8 times 4, which is 32. So I get a negative 16 plus 16. I get 0. So 4, 0 is my vertex. Like usual, I'll choose numbers on either side of 4. So let's try 2 and 3 on this side and 5 and 6 on this side. Plugging 3 into the equation, I get 1. And plugging 2 into the equation, I get 4. Realizing that it's going to happen on the other side as well. So I plot my points. 4, 0 would be found right here. 3, 1 is found right here, and corresponding 5, 1 is found on the other side. 2, 4 is found right here. Let's see if I can get it at the right place. And 6, 4 is found here. And we get a beautiful parabola that does something like this. And so remember what our goal was. Now we've got our graph, but our goal is to solve by graphing. And so the solution is whatever value of x makes this whole equation here, or this whole function, equal to 0. We see from our chart it's 0, and we see from our graph where the graph intersects the x-axis is at 4. So this 0 lets us know that 4 is the only solution. So x is equal to the set containing the number 4, and that's all. So here we have another problem where there's no real solution. This is kind of a word problem. We're going to model a situation, and then we're going to prove that there's no situation that can actually work. Take a look at this. Be sure to take notes. Find two real numbers whose sum is 6 and whose product is 10. So if I were to find these two numbers, let's call one x and let's call the other one z. So x plus z, the sum is 6. X plus z must equal 6. And then whose product is 10. X times z must equal 10. Now in algebra, we know that it is most easy to deal with equations when there's one variable. Right now we've got two equations, two variables. The way we deal with this is that we do a little bit of substitution. I'm going to only deal with x. So I'm going to rewrite z in terms of x. So since x plus z is equal to 6, I know that z is equal to 6 minus x. I'm going to take this value of z, plug it in here. So my equation now is x times 6 minus x is equal to 10. All of this has been shoved into this. So now I've got this equation, 6x minus x squared is equal to 10. What's the solution? Well, this is what we've been doing with the last few examples, finding the solutions of quadratic equations by using graphing. Let's go ahead and do that. So to do this, I'm going to move everything over to one side, and let me do that over here. I get a negative x squared plus 6x minus 10 is equal to 0. The next thing I'm going to do is look at the corresponding function, y is equal to all of this business, and I'm going to take that information and graph it. To graph this equation, I do like I always do. I start off with my vertex using a little negative b over 2a, plugging it back into the equation. I get that my vertex is 3, negative 1. The next thing I want to do is use that information to find some other points. Going backwards, 2, 1, going forwards, 4, 5. When I plug 2 into this equation, what I find myself getting is a negative 2. And when I plug 1 into this equation, let's do that quickly. 1, negative 1 is going to plus 6 is going to give me golly, negative 1 plus 6 is going to give me 5. 5 minus 10 is going to give me a negative 4. So I get negative 4 on both sides here. Okay, I would have gotten negative 4 if I did that right. I actually get a negative 5. And so I should have a negative 5 on both sides. I know you were probably looking at it like, why are you doing crazy math? My apologies. So now I'm going to graph this. And once I graph this guy, what I notice is it floats. It does not intersect the x-axis, which is here, at all, meaning there is no value, no matter how many values I put in here, that's going to yield a y value of 0. Therefore, there is no solution to this equation. And we can see that because this graph does not have an x-intercept, does not actually intercept the x-axis. Solve this particular function by graphing, and if an exact root cannot be found, state the consecutive integers between which the roots are located. Okay, well, this is going to be interesting. So we need to figure out if we can solve this. So we're going to start the way we usually do by actually trying to graph. So the first thing we do is we find the vertex, which is 2, 3, and then we plug away and we get the other information we need. So we've got 0 and 1 on this side and 3 and 4 on this side. When I plug 1 into this equation, I'm going to get a positive 2, and therefore the same thing will happen when I plug 3 in. When I plug 0 into the equation, I get a negative 1. So that lets me know that the same thing will happen when I plug in 4. So after plugging and chugging and after graphing, I'm left with this, and we see that we do actually have two solutions, but the solutions, let's highlight what we're talking about here, the solutions don't actually cross at a specific point or at a value that is an integer, at a whole number, negative or positive. And so the question is, what can we do? Well, they say if the exact root cannot be found, state the integer between which the roots are located. We could have seen that the roots were located between 0 and 1 and 3 and 4 just by looking at the x and y axis. And we can tell that because there's a change in sign when we go from 1 to 0. If we look at the graph from 1 to 0, there's a change in sign of the value, right? So I have this, well, let me circle it here. I've got this value that's positive and this value that's negative. That means somewhere in between there's some value of x that's going to give me this 0 value. Similarly, I could argue that somewhere between 3 and 4, since 3 yields a positive answer and 4 yields a negative one, we have a x value that would give me 0. So our answer, to answer the question the way we were asked it, to answer that, it says if exact roots cannot be found, state the consecutive integers between which the roots are located. So we get that roots can be found, roots or zeros can be found between 3 and 4, right? Between 3 and 4 and 0 and 1. 0 and 1. All right, this last one I'm actually using the textbook to discuss. We're going to write and solve an equation. So here's some information. On March 12, 1999, Adrian Nicholas broke the world record for the longest human flight. He flew 10 miles from his drop point in 4 minutes, 55 seconds using specially designed aerodynamic suit. Using the information at the right, that's this stuff over here, we're going, and ignoring air resistance, how long would Mr. Nichols have been in free fall had he not used the special suit? Use the formula h of t is equal to negative 16t squared plus h sub 0, where the time t is in seconds and the initial height is h sub 0 is in feet. Now this h sub 0 is sometimes referred to as h naught. It's like the beginning of the situation. And so let's look at the picture for a moment. He jumps out of a plane, there's some time that he's in free fall, then he opens up the parachute. And so we need to figure out how long this whole thing took. We're going to use this formula right here. H of t is equal to negative 16t squared plus h sub 0. So here's the height depending on the time, and here is negative 16t squared plus h naught. I'm going to ask you to review this in your textbook before doing the assignment that I have given to you. Also, try to use your calculator to take a look at how to do this. We'll talk soon. Take care.